So hello everyone, welcome to Mr. Exams Professor. So this is our digital logic and computer organization course, specially designed for JNTUK R23 Regulation and other universities. So if you are preparing for semester examinations and your goal is to understand only the important concepts that are enough to score good marks, then this course is for you. In every video, I'll explain concepts in the simplest possible way with handwritten notes, solved examples, and like some of the previous question-oriented discussions and exam tips. So by the end of the course, you should be able to write universally answers confidently without fear so that you can get very good marks in your semester examinations. Please note a point that this is not like a whole class lecture. So my aim is to get good marks for you in the semester examinations. So today I'm going to explain about the introduction, why binary number system, decimal to binary, binary to decimal, binary addition, binary subtraction, and examination tips. So don't worry, let's dive into the topic. So what is digital logic? Digital logic is nothing but the study of electronic circuits which works only with two values, which is nothing but 0 for low and 1s for high. So everything inside a computer works using only two electrical states. Either electricity is present or electricity is absent. Instead of calling them electricity on and off, we call them as 0 and 1. These are called binary digits. So binary digit is equals to bit, either it is 0 or 1. So why do computers use binary? Why binary? So imagine a room, imagining a room switch. So can it have three positions? Like no, it has only two positions, like on or off. Similarly, electronic circuits naturally understood two states. So binary numbers are used for understanding those two states. So now the number system, which is one of the most important topic and one of the most scoring concepts in this DLD. So decimal, which is base 10, binary base 2, octal base 8, and hexadecimal base 16. So decimal uses 0 to 9, like 10 digits. Binary uses only 0 and 1. Octal uses 0 to 7. Hexadecimal uses, this is important, base 16. Hexadecimal uses 0 to 9, A, B, C, D, E, F. So means A equals to 10, B equals to 11, C equals to 12, D is equals to 13, E is equals to 14, F equals to 15. So this table is extremely important. So just make sure you have to note this down. Some questions can be asked from this repeatedly. So this is very important. So now let's see decimal to binary. So this is decimal to binary. So for example, take a number, like any number, I took 25. So you have to do the repeated division method. So like 25 divided by 2, 12, 12 to 2 divided with 2, an output will come. This is nothing but the remainder. This is the remainder value. So if you divide 2 with the 12, 6, the remainder is 0. So if you divide 6 with 2, the remainder is 3. So 3 is divided by 2, the remainder is 1. 1 divided by 2, remainder is 1. So you have to see from bottom to up, which is 1, 1, 0, 0, and 1. You should not call it as 0, 0. You have to call it as 0, 0, 1. 1, 1, 0, 0, 1. So this is what we get. So always remember, read the reminders from bottom to top. This is one of the most common questions. So let's see the binary to decimal. So for example, I have took 10110 base 2. So by expanding, so with this, so like 0 to 2 power 0 into 2 power 0, which is not, so and 1 into 2 power 1, and 1 into 2 square, 0 into 2 power 3, and 1 into 2 power 4. By seeing this, you can understand these are the positions which I have given. So overall values, if you add it, we get 22. Okay, just understand it, don't by heart it. So binary addition. See, there are some few rules which you have to remember if you do the addition operation. So if you see this sum of the rules, you can get it. So if you see this, you can understand everything. Just make a note about this. And also my suggestion, do some research on your own. Do some research on your own and solve some problems. You will get a plenty of problems through internet. Don't worry about that. So this is nothing but binary subtraction. So these are the rules for binary subtraction method. Same, you can, by using these rules universally, you can solve any problem. So for this also do some research, okay? Because if I can explain in a video, I can explain about like 2 to 5 problems hardly, but if you search it by your own, you'll get an overview idea about the problems, okay? Don't worry, those are going to be very easy. So for this, if I have to say the real life example, think like think of a mobile phone. Yeah, whenever you click a button, internally millions of 0 to 1s, like 0 and 1s, are processed, like your photos, songs, videos, games, everything is stored only as binary numbers. So even your name in WhatsApp becomes binary inside memory. This is why binary is the foundation of the computer organization. So from my side, if I want to give a tips for the examinations, so they are frequently asked are like decimal to binary, binary to decimal, binary addition, binary subtraction, and basis of number systems, like why binary. If these questions appear, you should never leave them. These are very scoring questions. So for today's concepts, I have cleared like the digital logic. What is digital logic? Binary digits, number systems, decimal, binary, octal, hexadecimal, decimal to binary, binary to decimal, and like binary arithmetic. So I'm giving you homework, like convert some numbers into binary, and also convert some of the numbers like 1010101 into decimal. So practice binary addition, binary subtraction. So what my suggestion from DLD is, you have to do some practice on your own so that you can get so plenty of marks in the examinations. But this is not like a coding, like Python coding, like, so you have to do from your side. So that is very helpful for you actually. So in the next videos, I'll do explain everything about it. So don't worry. So today we have completed some of the fundamental concepts of digital logic and number systems. So in the next video, we'll continue unit 1 with fixed point representation, floating point representation, signed binary numbers, binary codes, and remaining important concepts needed for semester examinations. So thank you for watching. If this class helped you understand the topic, like the video, share it with your friends, and subscribe Mr. Exams Professor for complete JNTUK semester preparations. So see you in the next class. Don't worry, don't miss these videos. These are going to be very funny. Okay guys, thank you.